Alright everyone, today's video is going to be over the pH scale and calculations relating to the pH scale. But just a bit of a background information from last week's lesson. Don't forget that if substances are less than 7, then they're classified as acids. Substances that are greater than 7 on the pH scale are classified as bases. And if you have substances that are exactly 7, just like pure water, then that's classified as neutral. These are going to be the formulas that we'll be working with in today's practice problems or examples. The only thing you're going to need right now is to go ahead and open up your computers, as we're going to go ahead and be using the calculators on the computers, and I'll show you how to access that. Alright, so here I am looking at my computer screen, and most of you that are using the school laptops, you're going to have that Windows icon. Go ahead and press on that, and what you want to do is go to calculator, click on that, and the calculator is going to pop up. Now where you see standard, you're going to go ahead and change that. So where the 3 little lines are, you're going to go to scientific, and then it's ready for us to use for those examples. So let's go ahead and get started. Okay, on that first example, it's asking what is the pH of a solution that has a hydrogen ion concentration equal to 4.60 times 10 to the negative 5 molar concentration. For this particular question, they're giving us the hydrogen ion concentration and we're being asked to find pH. So the formula we're going to use is pH is equal to the negative log of the hydrogen ion concentration. If you notice, it's given to us, so all we're really having to do is plug that in where this bracket is, or where the concentration symbol is. Even though it sounds pretty simple, I guess the most difficult part of this problem is learning how to put it into the calculator. Alright, so let's go ahead and see what we know. So here's our formula again, and like I said, you're going to be substituting that hydrogen ion concentration for the one that has been given to you in the question. So it's going to look like this. Okay, simple enough, right? But now, how do we go ahead and plug that into the calculator? Okay, so I'm going to give you written down instructions on how to go ahead and enter that into the computer's calculator. To do this particular problem, you're going to notice that the way you enter it into the calculator looks nothing like the way it's written in the formula. Okay, if you notice, it's a little bit backwards. So the way you're going to start it is you're going to enter 4.60. Because this is times 10, there is a button on the calculator that says exponent. So you're going to press that button, and that's going to be the same as plugging in times 10. Once you do that, you're going to hit that plus minus to get the negative from the 5, and then the 5, and then at the end, you're going to press log. And automatically that answer is going to pop up. You're going to notice that answer will be negative, which you're going to change to a positive because of the negative that's here at the beginning of the formula. Alright, so let's go ahead and get started. So from our instructions, we're going to go ahead and type in 4.60 first. So 4.60. Okay, and then exponent. That exponent key is going to be found right here. Go ahead and press on that, and you're going to see something like that on your screen. Okay, so now you're going to go ahead and press the plus or minus. Okay, so here's our plus or minus to make it the negative symbol, and you'll see a change. And now we're going to press 5. And here we go. Okay, so now from there, we're going to go ahead and enter log. And that gives us our final answer. Remember that I said that you're going to change this negative symbol into positive to consider what was in the formula, which was that negative log. Okay, so now when we write our final answer, we're obviously going to round that to the nearest hundredth because that's too long of a number to write down. Okay, as we write down the answer, we're going to write down pH is equal to the positive 4.34. we're not going to put a unit. In this case, pH does not have a unit. And that's our final answer for finding the pH. Okay, on a side note, if I were to ask you, is this an acid or a base? That would be simple to answer just by looking at the chart. Okay, so looking at our chart, we find that 4.34 is definitely less than 7. So therefore, we would classify it as an acid. Okay, on the second example, it's asking what is the hydrogen ion concentration of a solution with a pH equal to 12.25? All right, so for this one, we're going to use a formula that looks like this. The hydrogen ion concentration is equal to 10 to the power of the negative pH. Okay, again, seems simple enough, but I'll go ahead and show you how to put it into the calculator. All right, so let's go ahead and take a look at what it would look like written down. So since the formula is 10 to the negative pH, we know that our given pH was negative 12.25. So it's going to be 10 to the negative 12.25. Now to enter it into the computer's calculator, again, it's a little bit backwards, but you're going to find out that it's going to give you the right answer if you plug it in like this. So you're going to go ahead and type in 12.25 first, the plus or minus key, and then this key that looks like this, 10 to the x. All right, so we start by typing 12.25. Okay, after that, our plus or minus key. It gives us that negative symbol. And then after that, 10 to the x. So there's that key. Click on that. And that's our answer. Obviously, really long for us to write. So we're going to go ahead and round that to the nearest hundredth as well. So when we write this, okay, we're going to write it like this. Okay, notice that on the answer, on the final answer, I went ahead and wrote times 10 to the negative 13th. Because if you notice on the calculator, it gives you E. This is calculator language, which is not what I want you to write down. What you need to know is that this means times 10. So you would substitute that E with the times 10. And obviously here's a negative 13th. So our final answer would look certainly like this. Okay. Don't forget that because it is a hydrogen ion concentration, you're going to put an M in this case for its unit. Again, molar concentration. Something we did not do with pH, but we will do with hydrogen concentration in this case. Now, as far as was this an acid or a base, we're not going to look at the answer for this answer, right? To see if it's an acid or a base. We're going to go ahead and look at what they gave us in the question. So in the question, they told us that the pH was 12.25. So the same thing you did earlier, you look at where 12.25 is, that's above 7. So we know that that's a base. All right, so we're on example 3. And for example 3, it's asking what is a pOH of a solution that has a hydroxide ion concentration equal to 1.50 times 10 to the negative 13 molar concentration. So now that we're dealing with hydroxide ion concentrations and not hydrogen ion concentrations, let me go ahead and go over the differences in regards to the pH scale. Okay, so we're going to find that if we look at the differences between a pH and pOH scale, they look a little backwards from each other. Okay. If we say that the pH is less than 7, then we say that it's an acid, and a pH greater than 7 is a base. Okay. For a pOH scale, if we say that a solution is greater than 7, or the pOH is greater than 7, then we call that an acid. If we say that the pOH is less than 7, then it's a base. But remember, for the pH scale, that's what we really want to use. That's what's widely used. But this is just as a reference. And when you deal with hydroxide ions, the more you have of those, then you're certainly looking at bases. The more hydrogen ions you have, then you're looking at acids. Okay, so we know that they're giving us the hydroxide ion concentration. Here's our formula. All we have to do is substitute the hydroxide ion concentration by the value that's given to us in the question. So this is what it would look like. pOH is equal to the negative log of 1.50 times 10 to the negative 13. Okay, so now it's again slightly different to put it into the calculator. But again, then again, it also comes out correctly if we do it this way, okay? So the steps would be type in 1.50, exponent, and then our exponent is negative 13, and then the log button. Okay, let's go ahead and do that on the... Okay, so something I want you to also notice with this other example, it's really similar to example 1. The only difference is that for example 1, we were trying to find the hydrogen ion concentration. And in this example, we're trying to find the hydroxide, or not the hydroxide, but the pOH, okay, given the hydroxide ion concentration. All right, so we're going to go ahead and pretty much follow the same steps. So we're going to put 1.50, okay, and then we're going to go ahead and click on exponent. So click on the exponent key. Looks like that. Because the exponent is negative 13, we're going to go ahead and press on the plus or minus and then type in 13. All right, and then we're going to go ahead and press on log. Okay, so that gives us our pOH. And remember what we did on the last one, on example 1, we're going to change that negative sign to a positive. So rather than putting negative 12.82, blah, 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 whatever it is, right? We're going to round it. We're going to put positive 12.82. And again, pOHs do not have units, just like pHs. No units are involved. So it's the answer for our question is pOH is equal to 12.82. Okay, I'll show you here in a bit on how do we know if it's an acid or base.
Nice, I got 82.
All right, so for our next example, example 4, it's asking what is the hydroxide ion concentration of a solution that has a pOH equal to 4.57. So if you recall from example 2, again, this is going to look a lot like that one. So it's going to be the hydroxide ion concentration is equal to 10 to the negative power of the pOH. Okay, so let's see how that looks. All right, guys, so this is what the formula looks like, and we're again plugging in that pOH, 10 to the negative 4.57, and just like before, remember it's not going to look anything like the way it looks here. So when we enter it into the calculator, these are the steps, just like in example 2. Go ahead and you first type in the pOH given to you, 4.57, the plus or minus because it's a negative 4.57, and now we're going to type 10 to the x power. All right, so let's go ahead and type that in. Let me go ahead and clear this. All right, so it is 4.57, and then our plus or minus, because it's a negative, there it is. And then the 10 to the x right here. Okay, so that gives us our hydroxide ion concentration. And it would be 2.69153, blah, blah, blah. We're going to round it. So E, remember, means times 10. So it's times 10 to the negative 5. So when we write it down, hydroxide ion concentration is 2.69 times 10 to the negative 5th. And again, just like the hydrogen ion concentration, hydroxide will use a unit, and the unit is M for molar concentration. And again, you know, we can go ahead and figure out what the pH is, but I'll tell you here in a bit. All right, guys, so we're finally at example 5. And for example 5, save the best for last, a lot easier. Okay, so in this example, there's 2 parts, and I did it just so you can see how it works, but you're going to find out it's super easy. So for part A, it says, what is the pH of a solution if the pOH is 6? And for part B, it says, what is the pOH of a solution if pH is 3? Okay, so This is the main formula that we're using. And I think for this one, we're not going to use a calculator. We're going to use our brains, okay? Which is totally okay. So let me go ahead and show you how to do that. All right, so I went ahead and broke it down a little bit further. And like the first one is asking, what is a pH? So if we kind of manipulate this, to find pH, it's simply going to be 14 minus a pOH. We just rearrange some stuff, which is not a big deal. So here we go. 14 minus a pOH. Remember, the pOH was given to us. It was 6. 14 minus 6. You can even use your fingers and your toes, and that gives you 8. So the pH is 8. Okay, so that means that since a pH is greater than 7, it's a what now? A base. Okay, good job. So now, what about the second one? The second one is asking, what is a pOH of a solution if pH is 3? Okay, no biggie, right? So here we go. pOH is equal to 14 minus a pH. Kind of the same concept. All we're doing is 14 minus whatever is given to us. So 14 minus 3, that gives us 11. So the pOH is 11. Okay, so that pretty much concludes our examples. But going back to telling you from the previous 2 examples that, hold on, let me tell you what the pH is. Let me go ahead and show you why I waited till this example. Okay, so on a quick note on example 3 and 4, since I wanted to come back just out of the sake of just letting you know, if you wanted to find out if this was an acid or a base, just very quickly, because you would be solving for the pOH. If you wanted to get the pH, you would go and use this formula. Once you find the pH, then again use a pH scale and then find out if it's an acid or a base. Same kind of concept with example 4, because they do give you the pOH, then you could easily just use once again the formula from example 5 and subtract this from 14 and find the pH, and again look at it where it lands on the scale. All right, so guys, I'm sorry there was probably tons of interruptions throughout the video. You probably heard my dog barking, you probably heard my kids talking. This was actually take number 5, so yeah, I'm gonna keep it. But I appreciate you all, miss you all. Anything you guys need, make sure that you guys email us or send us a message through Remind. Okay? All right, talk to y'all later.